Hi, I'm Mrs. D Math. Thanks for joining me today. We're going to be going over some examples on area of polygons in 7th grade math. So let's go ahead and get started. So area of polygons is something that we are putting together from previous information. We do know that the area is the space inside of a shape, and a polygon is just a two-dimensional closed figure made up of line segments. So this is going to cover quite a few different shapes. One of the other things we should know is that area is always labeled in square units. So you're going to see units squared, and those units can change between whatever the measurement is, centimeters, inches, feet, and so on. Today we're going to specifically look at parallelograms, triangles, and trapezoids. And all three of these have the formula there for you. So we're going to start with parallelograms. And the parallelogram looks similar to a rectangle. You can see that the picture or the image has a 90-degree angle for you. If you were to take this side of the parallelogram and move it to the other side, if we were to cut that off and move it over here and put it here, then this would be moved to the other side, which makes this image a rectangle. And we know that the area of a rectangle is base times height. So what we've done here is shown that if you cut off that edge of a parallelogram and move it to the other side, you've now created a regular rectangle. This is why the formula for the area of both is the same. I will say that when you're finding the area of any figure, the base and height are always created by the right angle. So the height of the parallelogram is not going to be this slanted side over here or this slanted side over here. It's always going to be the line that is perpendicular to the base. For a triangle, we also have 1/2 base times height. So here we can see if we were to take this triangle and double it and flip it around, since it's not a right triangle, it's not going to create a rectangle, but it is going to create a parallelogram, which we just saw is the same formula as a rectangle. So triangle is only half of that image. So our formula is 1/2 base times height. Again, your base and height have to be the two lines that create the 90-degree angle. So not the slanted sides, but it's got to be the two lines that create the 90-degree angle. If it's a right triangle, it's going to be the two side lengths that create the right angle, just like in this image. The last one we're going to look at is a trapezoid. And the trapezoid formula is a little bit more complicated. I can see that my trapezoid has two bases that are different lengths. And if I do the same thing I did with my triangle, and I create another trapezoid and flip it around, put them together, I have now also created a parallelogram. So essentially a trapezoid is also half of a parallelogram. But unlike a triangle, I have those two bases. So I'm going to take both bases, add them together, multiply by the height, which again is created by this 90-degree angle, and then I'm going to divide it in half because I only need half of that image for my area. So this is where the formula is derived from. Let's go ahead and see if we can practice some examples. So first we want to find the area of this parallelogram. So two things we need to pay very close attention to is which one is my base. That one's usually pretty easy to figure out. So the base in this case is 12. And then I want to find my height. And I have two other numbers that I'm given. And again, we always want to look for that right angle. And so the two lines that create the right angle are going to be my base and height. And I know this bottom line is 12, so that means that this line that's running perpendicular into it has to be 4 inches because these two lines are parallel. So this is also 4 is my height. So now I can just solve for the area. And I know that 12 times 4 is 48. This one is labeled in inches, so my answer is going to be inches squared. And that's it. Parallelograms are pretty simple, a lot like rectangles, but you have to be very careful on which one is your height and which one is your base. Now let's use our formula and find the area of a triangle. So we have area equals 1/2 base times height, area equals 1/2. And then my base and height. So again, we're looking for that right angle, and the two lines that form the right angle are going to be my base and height. So in this case, base is 18, and the line that runs perpendicular into that is 11. So now that I have my formula, there are a couple of ways I can solve this. And just a reminder, multiplying by 1/2 is the same as dividing by 2. I have a couple of options. I can go ahead and multiply 11 and 18 first, and then I can divide that answer by 2. If I have a calculator, I might want to just plug in 1/2 times 18 times 11. But I can also take half of either of these numbers, not both, just one of them. And in this case, 11 is an odd number, so I'm going to take half of 18. I know that 1/2 of 18 is 9, so now I have simplified my problem to be 9 times 11. So this means that the area of my triangle is 99 inches squared. So let's try one more example with a trapezoid this time. And again, we do need to make sure that we have all of our parts correct. I have two bases. Since they are adding together, it doesn't matter which one's which. And then I need my height. So I'm looking again for this right angle and the two lines that create the right angle. So in this case, it's 10, 8, and 5. Notice how the 5 runs perpendicular into both of them. This is also a right angle. It means the number I don't need is 7. So now I can plug this in. Area equals 1/2, base 1, 8, plus base 2, 10, times my height, which is 5. Now, I have to do my parentheses first. I still have to solve by using PEMDAS. So I can't take half of 8 or 10 until I add them together. So I'm going to go ahead and add those together first. My next step means that my area is 1/2. 8 plus 10 is 18 times 5. Now I can go ahead and take half of one of these numbers, not both, just one. Since 5 is an odd number, I'm going to take half of 18, which equals 9. So now the area of this trapezoid is 9 times 5, and that means that the area equals 45 inches squared. So once you've figured out what numbers go where in the formula, it usually is pretty easy to solve in order to find out the area of the shape. I'm Mrs. D Math. Thanks for joining me today for the area of polygons in 7th grade math. Have a great day. Bye.